In the previous video I was looking at the feasibility of corner junction boxes on modules, and I made a slight mistake to my own detriment, against my own argument. I said that the traditional way of wiring things up with the extension leads has a net result of 0. It has a net result of 2. So let's throw our lightning strike, shall we? Where's our lightning strike? Over here. Let's grab him, chuck him up here somewhere. Well, okay, here's our lightning strike. Now this one here is closest, so it has a magnitude of 4, hypothetically. This one has, through the middle of the panel on average, -3 back in the other direction. So we've got a magnitude of 2 here on the red cable and -1. That doesn't equal 0, it equals 2. So that was arguing against myself. The traditional way isn't perfect either to prevent wiring loops. So how does that compare to what I had myself? We just delete, go backwards and to go to this situation, which was this link here. We're going straight across, down there and across again, with a average here in the middle of the module as well. The lightning strikes up here. This time we've got a magnitude of 3 here. We don't have anything there because we're just going, we don't have any extension leads at all. We've got a magnitude of -1 in this direction now. That still has an average of 2, not 0. So even internally in a module, if you look closer, there's still wiring loops, no matter what you do. Let's look at this configuration, how all of the cells are wired up in series, potentially. I'm not saying that this is how modules are wired, but they've got to be wired up in some kind of configuration, and we've got to look at the flexibility of what is potentially possible. Is our lightning strike, even this one has wiring loops, because really the return in the other direction is offset by one cell. So the average is going to be an induced voltage. Around the corner here, we've got the U-turns longitudinally along the shock wave, if you would, from the lightning strike, the magnetic shock wave. Nothing's going to be induced in the cables longitudinally, but across here from cell to cell at the U-turns, this one here is going to have more voltage induced than this U-turn in the other direction. So therefore we're going to have a net voltage induced in the panel. Here we're going to move our lightning strike over here. Same thing here, but to a lesser extent, well, same extent. We've got more U-turns, but closer together. So that therefore will have a net induced voltage. Here we're looking at a possibility of a low current, high voltage cell, all in parallel. That's disastrous for wiring loops. All of those are in, all of this inductance from this lightning strike will be all in the same direction, no cancelling out whatsoever. So is there a perfect solution? The answer is clearly no. So does that mean that the potential for corner mounting blocks is going to degrade the resistance to lightning strikes? And the answer is no. It's just a whole lot of flexible options. Now what we have here is an option where the Jboxes are diagonal, very, very flexible. Here we have that situation here with a different design where the opposite corners here are return path, and then we have one polarity each in each corner with left and right handed panels. Here we have the simplest design here, because current modules have a Jbox on each side, so you just flip a cable out there and there, get rid of this Jbox, and end up with a negative down one long edge and positives down the other long edge. And this is particularly good if you have a extra low voltage charge controller, I guess, because all of these could be paralleled more easily. So as you can see, potential for helping out with low voltage charge controllers. Another possibility, whatever the case is, the point of this video is, are corner Jboxes feasible? And the answer is yes. So regardless of what the engineers come up with, will it reduce wiring underneath the modules? Yes. So let's go back to this situation. And here we are. We're looking at a potential way of getting rid of all this mess. So it's feasible. Is it the total answer? No, you don't need a conclusive answer. You just need the flexibility, the feasibility, the potential there. Now, the whole point, the regulators should be like the National Construction Code. The National Building Code doesn't tell you, you must have this entry into the bottom of the DC isolator. What they will say is, you must have a facility where if the ingress of water cannot get into the isolator, So they don't tell you how to do it. They don't tie your hands behind your back and make you jump through hoops. They say this criteria must be met. We don't care how you get there, as long as you meet this criteria. Otherwise, the Bird's Nest Stadium in London cannot be built. Simple as that. They'll say this engineering specification must be met, it must stand up to 1,000 years of bad weather, what have you. That is met. They don't care if it looks like a big Bird's Nest Stadium for aesthetic effect. So this philosophy is not brought over. It's more of a policing or authoritarian attitude where, okay, this is a mess because you haven't been provided proper engineering solutions to deal with it, and now you're making it up as you go on the job, which is absolutely woeful. But then we're going to tie your hands like, oh, look, you've penetrated the rail with saddles here. Somebody did that. Oh, now you've weakened the integrity of the rail. You can't do that. So now you've just eliminated that as a means of securing cables, as pathetic as it is. So now you've made it even harder. And as we saw, this guy here was working within that restricted criteria, and he's tried to go into the bottom here, make that lead less than 300 mil long. He's tried to get the earth across from isolator to isolator without penetrating the sides. It looks like a complete dog's breakfast, but that's how he's been told to do it. Now you'd have to fit a drain loop in there somewhere, cluttering it up even worse than it already is. These isolators, when you put them close together, won't allow for these fittings to work. Look, he's shaved that one down on the right and on the left. He's run out of holes. He's been forced to come out the top here of the AC isolator. It's just, it's nothing like the National Construction Code. They have a good philosophy. The electrical industry could learn from the building code. So whether you put, I love them. I reckon the idea of putting corner Jboxes and just little links across is a fantastic idea. But even if you don't like that, the criteria, the incentive there should be to say, if a panel manufacturer can come up with a solution that eliminates this wiring mess on the roof, then they will get more STCs. We don't care how you achieve that. But if you achieve it, then you will get more STCs. That was the whole point of my video regarding corner junction boxes.